What is up, guys? We're going to be taking a look at this lab, Authentication Bypass via OAuth Implicit Flow. It might be worth checking out a video from the CSRF playlist to get some context and some background regarding OAuth. Check out the lab's same site lacks bypass via cookie refresh. This implicit flow, sometimes referred to as implicit grant, is a deprecated, fundamentally flawed way of implementing OAuth. And the reason why it's referred to as implicit is that the client, i.e. the browser, maintains control of the bearer token. Remember, it's that token that allows us to access resources from the OAuth provider. The web app itself doesn't have a great way of knowing for certain that the user is properly authenticated with the OAuth provider. It has to trust the user to some extent and make assumptions based on the user's behavior. The implicit flow or implicit grant was originally designed to help single-page applications that maybe couldn't make server-side requests because they relied entirely on front-end code running in the browser. So it was necessary for the user to be able to communicate with the OAuth provider directly and maintain control over the bearer token. However, the secure way of implementing OAuth is to allow the server to have control over the token. It doesn't need to touch the user's browser at any point. So the flow of this is that the user is supposed to contact the OAuth provider, receives a code from the OAuth provider. The user passes that code to the web application. The web application makes a server-side request with the code and its client secret to receive the bearer token. The web application server then makes requests to the OAuth provider on behalf of the user. The user's browser doesn't need to be involved with that. That's a secure way of implementing OAuth. We're going to see the insecure implicit grant implementation of OAuth. Now, I will skip over some of the earlier steps. We're going to take a high-level overview of the series of requests that are made by the browser. If you want more information on the authentication with the OAuth provider, check out the video that we referenced. So here we are in the web application. We'll go to My Account. You can see that we get offered a login box, which is provided by the OAuth provider. So let's use our credentials, Wiener Peter. We'll choose sign in. We can then authorize which resources are allowed to be accessed on the OAuth provider. So we're giving the web application permission to access our profile and email on the OAuth provider. We'll choose continue. You can see now that we are authenticated with the web app as well as the OAuth provider. Now let's briefly analyze the flow of this. Anything in green is a request to the web app. Anything in yellow is a request to the OAuth provider. And if it's in orange, it's still a request to the OAuth provider, but it's specifically a post request with a body containing information. So first of all, we visit My Account. The web app recognizes that we don't have a session cookie, so we're not authenticated with the web app. It redirects us to /social login. Social login then sends our browser to the OAuth provider along with the client ID of the web app, a redirect location for after the OAuth flow is complete. And notice this response type equals token. So this tells us immediately that we're dealing with the implicit grant OAuth, because the secure version of OAuth, we request a code, which we then pass back to the web app, which then makes its own authentication call to the OAuth provider. But here in this case, we're asking for the token directly to be delivered to the user's browser. So we then get redirected to the OAuth provider. We're given some cookies, such as an interaction cookie that's going to track the OAuth flow. Eventually, we get to the sign-in box provided by the OAuth provider. We then make a post request. You can see the body there, username equals Wiener, password equals Peter. Once we're authenticated with the OAuth provider, we then get directed to the confirmation page. Are we happy to give access to our profile and email to the web app? If we confirm, another post request is dispatched. And at this point, the OAuth flow itself is complete. So now we're sent to the OAuth callback location back on the web app. Notice the redirect link. After the hash in the URL, we have the access token. So we can see that the bearer token is revealed directly in the URL, which creates a host of potential security problems. For example, this is something that can now potentially be stolen through a cross-site scripting attack, for example. Perhaps if the victim's browser is successfully dispatched elsewhere, this access token could end up as part of the referrer header set by the browser. There are a number of different ways this access token, which essentially represents access to the resources on the OAuth server, can fall into the wrong hands. It's much more secure that this is handled by the server, but in the implicit grant version of this, it's going to be handled by the client. And so when we get to the /OAuth callback route, back on the home web application, you'll see the first thing the web app does is request that the user attempt to access resources from the OAuth provider, making use of that new bearer token. So you can see get request headers, authorization, bearer plus token, and you can see that that was extracted from the URL. Look at window.location.hash.substring1, so everything following the hash. Then we assign the value of token to URL search params.get access token. So we retrieve the access token from the URL. We then dispatch it as part of a GET request to /me. So presumably we are retrieving profile information from the OAuth provider. Of course, we need to include our bearer token as an authorization header. Then when we retrieve the response from the OAuth provider, we convert it into JSON first of all, then we use that information to create a second post request to the web app itself to /authenticate. So we're including the email from the response, .sub, which appears to be the username, and we do also send the token itself to the web app. Now, this is not necessarily a standard part of the implicit grant flow. For example, the user's browser could simply use information returned by the OAuth provider to populate dynamic content on the web page, and it doesn't need to explicitly send the token to the web app. However, in this case, the web app is offering its own authentication. It's logging users in with the web app itself. So it makes sense it probably wants to perform some level of validation on the token. The token is sent to the web app. If the web app decides that the token is valid, then it can also authenticate the user and set its own session cookie. There's also technically nothing to stop the web server at this stage making its own calls to the OAuth provider using that bearer access token, but the reality is it's probably not doing that in this case because that's the whole point of implicit grant flow, is that it's the user's browser that's making the calls to the OAuth provider. Now, we don't know exactly what's happening on the back end in terms of token validation, but we do know it's using information that's sent as part of the post request body to /authenticate to authenticate the user and log them in using the email that's apparently been returned by the OAuth provider. It's just that this is client side, which means that we can manipulate this. So he can see a copy of the post request to /authenticate. We see the token included in the request, the username and the email apparently returned by the OAuth provider. And then from that, we get a 302 found response, and you can see that the session cookie is set in the user's browser. The user is now authenticated with the web app. So now here is a copy of the request to /authenticate in BERT repeater. Let's see what happens if we change the email in the post request body. The objective of this lab is to log in as carlos@carlosmontoya.net. So we've changed the email in the post request body. Now, ideally, if there's good validation taking place server side, maybe the web app figures out that this token is not actually associated with this particular email. Whereas in this case, it's trusting the information that's coming from the client. It may be performing some checks on the token. It might, for example, be checking whether this is a valid token, but it's certainly not checking whether this token is correctly associated with this particular user. So now if we send this request, we still get a 302 found response, despite the fact that we've changed the email in the post request body. We can then choose request in browser in original session. This gives us a link to copy. Let's paste the link into our browser. And you can see we get the message, congratulations, you solved the lab. If we head to my account, your username is Carlos. Your email is carlos@carlosmontoya.net. Now for a bit of fun, let's see if it's validating that token period. If I change one of the characters in this token, you can see we get 500 response. So it does appear to be performing some validation on the token. It's just not checking whether that token is associated with that specific user. Now, although there's probably a way to augment the security of this particular approach and run better validation on that token, provided from the user's browser. The key mitigation here is to completely ignore implicit grant OAuth or implicit flow, as it's called in the lab title. This is not how secure OAuth is supposed to work. The user's client is supposed to request a code from the OAuth provider. The browser sends that code to the web application. The web application then uses that code to retrieve a bearer token, which it keeps to itself and uses for any subsequent requests to the OAuth provider. The user's browser never needs to know or touch that specific token. The web application server makes the server-side requests to the OAuth provider on the user's behalf. So key mitigation, don't use OAuth implicit flow. All right, that's pretty much it for this lab. Thanks for checking out the content, and I'll catch you guys in the next lab.